here we are. Number 11 says, find the area of this circle. Use 3.144 pi. Well, we can see that the radius is 6 inches. You need to know, sorry about that, you need to know what the formula is. And I want you to write the formula. Area of a circle equals pi r squared. Now, I was told that the radius is 6. To square it, that's 6 times 6, which is, of course, 36. Now I can multiply that times pi. So 3.14 times 36. Let's just do that quickly. Add that up. You get a 4, a 10, carry the 1. You get a 13, carry the 1. You get 11, but I have 2 decimal places, so it's actually 113.04 what? It said inches. Inches what? We're doing area, so it has to be squared. Area is always squared. 12. Finish this table. You should be really, really, really good at this by now. So the first one had 7 over 20, so I'm going to divide 20 into 7. Can 20 go into 7? No. Can it go into 70? Yes. How many times? 3. That would get you 60. That would leave you 10 left over. Add a 0, drop it down. Can 20 go into 100? Of course, 5. So my decimal is 0.35. What's the percent? Easy peasy. Multiply times 100, it's 35%. Then it gave you, oh, there we go, 6%. Well, that is the same as 6 over 100, right? Or 6/100ths. It's going to be the answer over here is 6/100. So I'm just going to write that right now. The decimal for that is 0.06. All right, this is my fraction, but I can reduce that. 2 can go into 6 3 times. 2 can go into 150 times. I can't reduce it any further or any farther, so that is my fraction. 15. 15 gives you this top portion, 2.5 times 10 to the 6th times 1.3 times 10 to the 9th. I'm going to gather my like numbers, because I can do that with the associative and commutative properties. So I'm going to put my decimals together. 2.5 times 1.3 times 10 to the 6th times 10 to the 9th. And I know, because I did this beforehand, that these two decimals multiplied together is 3.25, and that is a correct form for a scientific notation, the decimal coming after the first digit, times 10, and I just have to add those to the 15th. Bammo, done. 14. 14 is going to show you this shape right here. All right? And the first thing it's going to say is name the quadrilateral and find its perimeter. Well, what kind of quadrilateral is this? Parallelogram. Oh, you're right. It's a parallelogram, which is just fun to write. Parallelogram. And what is the perimeter? Well, you're just going to add them all up. But what I like to do is I like to write it in an algebraic sentence. So I write it is 10.5 times 2 plus 14 times 2. And I know that's 21 plus 28. So it's going to be 49, what was it? Centimeters. I don't have to square it because it's asking, this is the perimeter. Now it wants to know the area. And you are going to write this formula for parallelograms, squares, whatever. How you find the area is area equals base times height. And right here, we can see the height as the dotted line, and the base is 14, so 14 times 10, easy. All you got to do is add a 0 after the 14. So it's 140 what? Centimeters. We're doing area, so it's what? Squared. 140 centimeters squared. 16 simply says 15.4 equals 1.4 p. That means I have to divide. I need to isolate p. So I'm going to divide 1.4 into 15.4. Goes in to 15.4. I'm going to move my decimal over 1 so I have a whole number. Move this over 1. And I'm going to put it right there in case it goes past. I won't forget that decimal. So 14 goes into 15 how many times? Once. Get 14. Oh, look. 14 goes into 14 how many times? Once. So P equals 11. Okay, 17. Z plus 4/9 equals 1 1/3. I have to isolate Z, which means I have to subtract 4/9 from both sides. So can I take 4/9 away from 1 1/3? No, I have to have common denominators. So I'm going to multiply that times 3, bam, turns into a 9. Multiply that times 3, bam, turns into a 3. Now, oh, that's terrible. Now I have 3 over 9. Can I do it yet? No, because this is 4, so I have to borrow. I have to change this one into 9/9. So this will actually be 12/9 minus 4/9, which is going to give me 8/9. All right, here we go. The problem that never ends, because we have to work. We're going to write it out as many times as it takes to get it correct. All right, we have to go the innermost first, right? So this is 3 times 25 minus 7 squared minus 4 times, okay, now I can finally do that, 7. Okay, now I have to do still the innermost in here, so I do 3 times 25 minus 7 squared minus, what's 4 times 7? 28. Okay, still have to work within my parentheses here, so 3 times 25 minus, now I'm going to go ahead and do this because that's 49 minus 28. Okay? See, it doesn't matter what symbols I'm using for inclusion, just as long as I'm using symbols of inclusion. So now I have 3 times 25 minus, well, what's 49 minus 28? That would be 21. Now I have 3 times, what's 25 minus 21? 4. Look, 3 times 4, easy, easy, is 12. I want you to write each step because I want you and your brain to know exactly what you're doing every step of the way. Number 19. I want you to write this in algebraic additions. We're going to get rid of this double negative. We're going to say, all right, this is really -3 plus -4 plus the opposite of -7 plus -8. All right, so the opposite of -7 is going to be +7. So you know what? This is +7. This is going to be -7. -7 plus +7 is 0. Plus -8. Guess what my answer is? -8. Didn't really have to do much more than that because I could see that that's going to be -7. This is going to be +7. They cancel each other out. The only thing remaining is -8. All right. Here we go. This, they want you to find the missing numbers in the table using the function rule, which is y equals 2x plus 1. Then graph the pairs on a coordinate plane and draw a line through the points. All right, so if it's 2x plus 1, 2 times 0 is still 0 plus 1. That would be 1. Okay, so there's 1 point. 1 times 2 would be 2 plus 1. That would be 3. And, oh, that's terrible, 3. Then 2 times 2 would be 4 plus 1 would be 5. Gosh, there. So, now on a coordinate plane, oh, let's see if I can do this one-handed. Oh, I don't know about this. All right, bam, 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 bam. Doodly doodly doo. That's my x. Here's my y. All right, so the first one is 0 and 1. Then I have 1 and 3. And then I have 2 and 5. 1, 2, 3, 4. Oop, put another mark up there. 2 and 5. And then draw a line through it, which is going to be terribly crooked one-handed. All right, there you go. And that is the entire test. We are going to do very well, aren't we? Yes, we are, Mrs. Van Zalen. All right. See you in class.